So today we're going to demonstrate how Ersilia's automated model contribution pipeline works. Now, why did we need to automate adding new models to Ersilia? Originally, adding a new model involved a lot of manual synchronous steps, which wasn't scalable nor conducive for working with people in different time zones. So let's say I'm a researcher and I want to contribute a new model that aids in antimalarial research. So the first thing I'll do is I'll go over and I'll open up a new model request issue. So I'll go to Issues, click on New Issue, go to Model Request, and I'll click on Get Started. So to save some time, I actually have this filled out right here. You can see I've added a title, model name, model description, which is usually, if the model's from a publication, it'll be a summary of the publication. Slug, which is a unique identifier that can be used to filter for the model. Tags to help find the model. The link to the publication, the link to the source code, and if applicable, and license. So I have this all filled out. I'm going to hit Submit Issue. And my issue has been successfully submitted, and now I'm going to wait for a member of the Ersilia team to take a look at this and approve it. So as you can see here, my model has been approved by a member of the Ersilia org. This /approve comment starts a couple of GitHub actions which will automate the repository setup. And as you can see here, the action is currently running, and what it's doing is it's creating a new repository and initializing the repository with information from the model request issue. Once the action is finished running, I'll be able to fork the repository and add my changes. So the action is finished running and has added this comment on my model request issue, notifying me that the new model repository is ready for me to work on. This comment also has information on the next steps I need to take to add my model changes. So I'm going to take a look at this new repository. You can see here the action has already set up the repository's file structure for me. The action has also initialized the repository with information from my model request issue. And this repository doesn't contain my model code yet, so I'm going to create a fork of this repository and start adding my changes. Okay, now that my forked repository is ready, I can work on adding my model changes. I've finished updating my forked repository with the model architecture, parameters, and dependency changes. Now I'm going to open a new pull request to add my changes to the Ersilia model repository. So I'm going to click on Create Pull Request. And to save some time, I've already filled out a pull request with my changes here in a separate tab. I've added a title and description. I've also linked the original model request issues so reviewers have that additional context. Once I'm happy with my changes, I'm going to click on Create Pull Request. So as part of continuous integration, or CI for short, a few actions will automatically start up once my PR has been created, and these actions will run a linter on my code changes, run some security checks, and test the model to make sure that it's going to run with the Ersilia CLI. Now that these actions have finished running, I'll wait for someone from the Ersilia organization to review, approve, and merge my pull request so the Ersilia model repository is updated with my changes. So my changes have been approved and merged by a member of the Ersilia organization. Once the changes have been merged as part of continuous development, or CD for short, a few GitHub actions will automatically start running, and these actions will test to make sure that the model runs properly on the Ersilia CLI, and will update the Ersilia Model Hub, which is Ersilia's catalog of available models, with the updated model metadata changes. So once all the tests pass, a GitHub issue will be opened for a member of the Ersilia organization to go and perform a final model validation. Another action will also notify the team in Slack that this model is ready to be reviewed. Once my model has been validated by a member of the Ersilia organization, it'll be ready for me to use. Now that my model changes have been merged, my model is ready to use. I'm just going to take a note of this identifier. It'll make it easier for me to use this with the CLI. So I already have the Ersilia CLI installed. The first step I'll do is I'll fetch the model. Okay, my model's been fetched successfully, so it's available for me to use. And just to check, I'm going to use the card command, which will print out information and metadata about my model. And you can see here a lot of this information was actually provided in the original model request issue. So the next step will be serving the model. And what this will do is just start up a local API that I can call to make predictions against. So I have this file called my molecules, and it has a list of about 30 small molecules randomly generated. And let's pretend that I'm an anti-malarial researcher. I have these molecules and I want to see which ones are most likely to have anti-malarial potential, just because I don't want to spend the time and resources to test every single one of these in the lab. So I've served the model. I'm going to call the API to run predictions. I'm going to provide the path to the my molecules file, and I'm going to output it to a file called my output. Okay, so my model is now finished running its predictions. So I can take a look at this my output file. And if I scroll up to the top, we'll have the header. So key, which is just a random identifier, input, which is the small molecule, and then the score, which is the likelihood that this molecule has anti-malarial properties. And now I can go back to the lab and run experiments on the molecules that are most likely to have anti-malarial properties instead of all of these molecules, which will save me some time and resources. That's it.